From a superficial view, 0 and infinity may appear to be two opposite ends of a spectrum. 0 defines the presence of no numerical value, meaning nothing, while infinity represents a continual increase in some value. How could these two numerical representations possibly be the same? We will require the use of logarithms. These functions can be interconverted with values that have exponents. For instance, if you had y is equal to the log base b of x, then this would be the same thing as saying that b to the y power is equal to x. This is the sort of interconversion I'm referencing when speaking of logarithms. Now, if no base is specified, it can be implied that the base present is 10. For example, log of 1 will be equal to 0, since anything to the power of 0 is equal to 1. This means that 10 raised to 0 is equal to 1, which is true. Things change once we try to take the log of 0. Nothing to a certain power will give us 0. The only thing that can approach 0 is negative infinity. Eventually, a number will become so small, it can be estimated to be 0, however, it will never truly reach 0. Infinity in terms of logarithms is expressed as the value positive infinity. When positive and negative infinity are combined, one can make the mistake of assuming the answer to be 0. The real answer is undefined, as the values of infinity are undetermined rather than being concrete real numbers. Another concept that makes use of negative and positive infinity are limits. They are an approach used in calculus to approximate values on a graph. I will not speak on them in this video, but I thought they were worth mentioning. I'll provide you with their basic structure in case you are interested, and that would be limit as x approaches a of f of x is equal to b, for instance. Remember that these letters are variables, so they could in fact be any values. One group of individuals who assumed 0 and infinity to be the same were the Mayas. They were Mesoamerican Indians and innovators in the field of math. They developed mathematical systems that allowed for trade to be understood in terms of addition and subtraction. Moreover, they devised astronomical calculations that proved to be accurate further down the line. Koshilova and Krianovic et al. Provided a potential explanation as to why the Mayas assumed such concepts to be the same. These two individuals conducted extensive research with respect to the matter. It appears the Mayas took a more philosophical approach. There is a deeper philosophical meaning in how nothing and infinity can be related. What makes them most similar to one another is that they both represent absence to an extent. 0 is simply the absence of any value, while infinity is reached when no defined limit is present. From a mathematical standpoint, it is evident that 0 and infinity are not the same. The Mayas may have excelled in several areas relating to math, but their belief of 0 and infinity being the same is not quite accurate. If 0 and infinity are not the same, then can it be said that they are polar opposites? This is another perspective we can evaluate. Infinity itself is an abstract idea used to represent the largest value possible. It is not a concrete number. The opposite of infinity would be the smallest number possible. This number would have to be slightly greater than 0. It cannot be 1, since there are values that come before it that represent a smaller quantity. 0 itself cannot be the answer, since it does not express any value. The only answer that makes sense would be negative infinity. A number so small would be needed that it could only be larger than 0 by a small difference. As we discussed previously, negative infinity can be estimated to be 0. Therefore, there is no exact value that can represent the opposite of positive infinity. Only another abstract concept, negative infinity, can behave as the antithesis of positive infinity. All in all, it appears that 0 and infinity are two concepts that are neither the same nor opposites. They are only ideas used to simplify our understanding of abstract measurements.